Alright guys, today we're looking at solving word problems with exponential equations. Now, with these exponential equations, there's two different types of equations. There's one where the exponent is a single number, and there's one where the exponent is a fraction. And those items in the exponents are the time values from your problem. Okay? Talked in here about how you got exponential growth, exponential decay, cell splitting, things like that. All right, so if you look at these exponential equations, they share the letters A and B in common. So in both of these, the letters A and B are the same thing. The letter A is what's called the initial value. All right, another way to say initial value is the beginning value. So whatever the value is at the beginning, that's your letter A. It should be easy to remember because A is the first letter of the alphabet, or it begins the alphabet. B is your growth or decay factor. So if you're growing, that number should be greater than 1. If you're decaying, it should be a fraction or a decimal. It's less than 1. And X, here and here, is your time. Now, if you look over at this little piece right here, it explains to you a little more about X and T. X is the total time. Okay, so if it says, how many mealworms will the class have for their experiment in 3 months, that 3 is the total time. If it says, something like, if you start with 100 strands of virus, how many would you have after 2 days? That 2 days is the total time. That would be your X. Okay, those were the last sentences in example 1 and example 3. T is the time it takes the base to repeat. Okay, so something like every 30 minutes. Okay, it might say, for instance, example 3 says a particular flu virus triples every 12 hours. So that 12 would be your T, because that's how long it takes to repeat. Example 3 goes on to say, if you start with 100 strands of virus, how many would you have after 2 days? So that 2 is the total time, and that 12 hours was your T value. So the T value is the time it takes to repeat. You can remember that because repeat ends with T. T is time to repeat. Now, some things you need to write down in this little gap here on your paper. If it says, if your word problem says every day, month, year, etc., then you would want to use the y equals a times b to the power of x, okay? Because in that case, every day, every month, every year, in that case, your t value would be 1. Okay? And anything divided by 1 is whatever's on the top of the fraction. Okay? Now, if it says something like doubles every 2 days, then that's where it repeats. This would be a t value because that's how long it takes to repeat. All right, so you would want to use, with this one, you're probably wanting to use the y equals a times b to the x over t. Now, that wouldn't be the only thing it says. It would say doubles every 2 days, and it might say what's the end result after 4 days. Okay, so you put 4 on the top, 2 on the bottom. One other thing as you're working these, especially when you're working these over here with the fraction exponent, you got to look for different units. Okay, you got to look for different units. So this one might say it doubles every 2 days. How many items of bacteria are there after 2 weeks. Okay, so if you had 2 weeks, and that's your X value because that's total time, and you had 2 days, and that's your T value because that's how long it takes to repeat. I'm talking about this example right here. Okay, you got to convert weeks into days. All right, in 1 week there's 7 days, so in 2 weeks there's 14 days. So this 2 weeks needs to become 14 days, so your X value would be 14. You got to have the same units in that fraction. Let's look at some examples here. In June, a 5th grade class started out with 10 mealworms. Now, you ought to be underlining some words. Started out, that's beginning. All right, that's your initial value. Started out with 10. All right, so I should know right now that A is 10. A is the initial value, it's 10. 5th grade class started out with 10 mealworms for an experiment. The population of worms will double every month. Will double every month. So right now we see every month, so we should know that we're using y equals A times B to the X. That's what we said on the slide before here. If every day, month, year, etc., A times B to the X. Now going back to that sentence, it also says double. If something doubles, that means you multiply it by 2. Now, that value, the double, the triple, the cut in half, all those words are your B values. Those are your growth or decay. Doubling is growth. So in this case, B is 2, because if you double, you multiply by 2. The question is, how many mealworms will the class have for their experiment in 3 months? So, we'll write double next to 2 just so you know where the 2 came from. All right, so we'd set up our equation here. We got y equals A, which is 10, times B, which is 2, to the power of x. Now, in this case, our x value is our number of months, which is 3. So we've got 10 times 2 to the 3rd power. And when you just type it in, okay? Now, when you type that in your calculator, to get the 3rd power, all right, you have to hit, obviously you'd hit 1, and you'd hit 0, and you can hit left parenthesis, and you'd hit 2, right parenthesis. To get the 3rd power, you got to hit this button right here, the caret button. It's right there above division. And then after you hit caret, obviously you'd hit 3 and then enter. Okay? And the result is 80. So you have 80 mealworms. Just to recap real quick to tell where A, B, and X all came from. All right. Started out, that's initial value or beginning with 10 mealworms. So A is 10. The population of worms will double. Double is the growth. All right. So B is the growth. That's got to be 2. Double means multiply by 2. Every month tells us that we're using this equation right here. Y equals A times B to the X, because every month is every 1 month. That means that T would equal 1. All right, and then it says, how many mealworms will the class have for their experiment in 3 months? 3 months is the total time. So that's why 3 is X. If you wanted to write the fraction and, T is 1 because it's every month, you'd write 3 over 1. Well, 3 over 1 is still 3. So you don't have to write over 1 when you're talking about something that happens every month, every day, etc. Okay? Let's go to example 2. All right, this one, it says each year the The local country club sponsors a tennis tournament. Play starts with 128 participants. Starts with 128. That means your A value is 128. During each round, half the players are eliminated. Each round. Okay, that's like each day, each year, each month. All right, so that means that we are using y equals a times b to the power of x because it says each round. That means every one round. Half the players are eliminated. So half, they're going down, they're decreasing. That's decay. So your b value is 1/2 because that's the amount of players eliminated in each round. How many players remain after 5 rounds? So the total amount of time, x, is 5. That's the number of rounds that we're looking for. So now it's a matter of plugging our numbers into our equation. Got y equals a is 128, b is 1/2, and x is 5. Again, each round, that means that the t value would be 1. So if you put 5 over 1, it's not going to change it. All right? Now, when you punch it in your calculator, remember to get this fraction of 1/2, you could put 0.5 in the parentheses. That would be fine. But to get that fraction of 1/2, you need to hit Math, left, Enter. And once you type this all in, it results in 4 players. All right, let's move to one where you have to use a fraction. All right, this is one I alluded to earlier. Each year, a particular flu virus triples every 12 hours. Okay, so it doesn't triple every hour, every day. It's every 12 hours. So this is one where we are going to want to use the fraction exponent. Y equals a times b to the x over t. Again, x is the total time, and t is the time it takes to repeat. So this flu virus triples every 12 hours. So 12 hours is your t value. My t value is 12 hours because that's the time it takes to repeat. Now, the repetition that's occurring is triple. So the b value, which is your growth or decay, is 3 because triple means to multiply by 3. Go to the next sentence. If you start with 100 strands of the virus, start with 100. It means A, or the initial value, is 100. How many would be left after 2 days? 2 days is the total amount of time. So that's your x value. Here's the problem, though. My x value, which would be on top, is in days. My t value on the bottom is in hours. That's a problem. So what I want to do is convert 2 days into hours. Well, 1 day is 24 hours. 2 days is 24 times 2, or 48 hours. So for my x value, I'm going to use 48. Separate these out for you. For my t value, I'm using 12, x value is 48, b value is 3, a value is 100. From here, it's a matter of writing them in the equation. A is 100, b is 3, x is 48, and my time is 12, or my time it takes to repeat is 12. So when I type this in, I would type in 100, left parenthesis, 3, right parenthesis, and then after I type this right parenthesis right here, I'm going to type the caret button. It's going to give me an exponent. And then I'm going to type math. I'm going to go left. Then I'm going to hit enter. And it's going to give me the blank fraction so I can put in 48 over 12. Okay? And your result here is 8,100 strands of this flu virus, or 8,100. All right, look at example 4. E. coli bacteria double. All right, so there's double. All right, if we're doubling, we're growing, so that is our B value. Our B value is 2. In population, every 30 minutes. Okay, so it takes them 30 minutes to double. So that means that our T value, the time it takes to repeat, is 30. And go ahead and write minutes there so you know the units of measure. So every 30 minutes, we haven't found A or X yet, but every 30 minutes tells us that we're using the formula with the fraction in the exponent. A times B to the X over T, total time over time it takes to repeat. All right, if the initial population, holy cow, it tells you initial right off the bat. Initial population is 85, so that means A is 85. What is the population of the bacteria after 3 hours? And then it wants it after 12 hours. Well, let's start with 3 hours. Now, let's convert the hours to minutes so that we have the same units here. All right, so 1 hour is 60 minutes. So 3 times 60 would be 180. So the X value we want to use for the first one is 180 minutes. Okay, it's asking you 2 questions here. It's asking you after 3 hours and then after 12 hours. So let's see. After 3 hours, our equation would look like this. Y equals 85 times 2. Our X after 3 hours is 180. Put that on top. And our T is 30. Put that on bottom. Okay, and that results, once you type that in, 5,440 bacteria. Now, the other X value it wanted us to find was 12 hours. Okay, but again, you want to convert that into minutes.
Mr. DeLay, I got it.
You good?
I, who have not looked at the calculator, had just picked it up.
All right, so we're going to convert 12 hours into minutes. So we're going to take 12 and multiply by 60.
Just out of curiosity, when,
Let's see. All right, so 12 hours is 720 minutes. So I'm going to come down here. I'm going to do the same thing I did just a second ago. 12 hours, I need the same formula, except on the top of the fraction, I'm going to put 720. So I need y equals 85, which is the initial value, times 2, which is the growth. This time it's to the 720 over 30. And the growth here is very drastic. So it's 1,426,063,360 bacteria after 12 hours. So you can see that 9 hours later, there's a drastic increase. That's why these are called exponentials. All right, example 5, population of mice quadruples. That means you multiply by 4 every 6 months. Not every month, every 6 months. So again, here we're using y equals A times B be x over t. All right, A is 2, because it says if a mouse nest started out with 2 mice, all right, so the start is 2. The B value is 4 because it quadruples. The T value is 6 months. That's how long it takes to quadruple. How many mice would there be after 2 years? So X is 2 years. Now we want to convert years to months. Well, 1 year there's 12 months. In 2 years there are 24 months. The reason we converted to months because the t value was in months. So we're going to plug our items in. We got y equals 2 times 4 to the 24 over 6. And that gives us 512 mice. The last one, in sporting tournaments, teams are eliminated after they lose. The number of teams in the tournament decreases by half. All right, so that means our B value is 1/2 or 0.5 with each round. If there are 16 teams left after 3 rounds, how many teams started the tournament? So, we don't know A. All right, what we know is that the y value is 16 because there's 16 teams left after 3 rounds. So the x value here is 3. So what I want to do is plug all this in and see if we can figure out what A is. So y is 16. Y is 16. We don't know A. B is 1/2. And x is 3. Okay, so the first thing we want to do is take 1/2 and raise it to the 3rd power. 1/2 to the 3rd power is 1 over 8. So I've got A times 1 over 8. To get rid of that 1 over 8 and get A by itself, I need to divide. Divide by 1 over 8. Divide by 1 over 8. And 16 divided by 1 over 8 is 128. So, in the beginning, there were 128 teams in the tournament.